In this observation, a mass of sugar was added to the tap water. The position of the widget in the fluid medium was observed and recorded. Other factors can potentially affect the position of the widget in the medium. The main factors that could have altered the position of the widget are temperature. The experiment was done in the morning and not in direct sunlight. Medium movement, disturbance of the medium. The experiment was done in a quiet room at the back of the house. The video shows that no significant disturbance of the medium from external influences occurred. What the observation visually showed. 1. When the mass of sugar was added to the tap water, the position of the widget in the medium changed. 2. The widget initially moved its position in the medium from a horizontal position to a vertical position. 3. The widget in the vertical position accelerated and moved towards the top of the medium and stayed there for the duration of the remainder of the video. Explaining what happened. 1. The mass of sugar at the bottom of the container started to dissolve into the medium. 2. The mass of sugar at the bottom of the container dissolving into the medium formed a heterogeneous mixture. That just means that the sugar was not equally distributed throughout the medium, resulting in a density gradient. 3. Density gradient. The mass per centimeter cubed of the medium is greater at the bottom of the container compared to the middle of the container. The middle of the container has a greater mass, number of particles, of sugar per centimeter cubed of the medium compared to the top of the medium. 4. There is also a concentration gradient in the container, the quantity, number, of sugar particles per centimeter cubed of the medium. There is a higher concentration of sugar particles at the bottom of the container relative to the top of the container. The mass of sugar that was at a high concentration in the bottom of the container was continuously dissolving into the medium and diffusing throughout the medium. A solute, the sugar, will diffuse from an area of high concentration to an area of lower concentration. In this situation, the sugar will be diffusing from the mass of sugar at the bottom of the container towards the top of the medium. Although this presentation will be focusing on the diffusion of dissolved sugar in a sugar solution, it must be remembered that water diffuses as well. The water will also be diffusing through the sugar solution from a high concentration of water at the top of the container to an area of low concentration of water at the bottom of the container. The diffusion of water is termed as osmosis. How do the sugar particles diffuse throughout the medium? The dissolved sugar particles will diffuse through the sugar solution water medium by their thermal motion and by collisions with other particles. Moving and being pushed in all directions, some of the sugar particles will stay in the area of high concentration of sugar particles, whilst some of the sugar particles will move and/or be pushed into areas of the water where there are less or no sugar particles. This is a reasonably slow process for the diffusion of sugar since the single particle of sugar, sucrose, has a large mass compared to the water molecule itself and other molecules that dissolve in the water. Presented is a very simplistic model of a sucrose sugar particle in water. The purpose of the diagram is to illustrate the difference in size between a sucrose sugar particle and the water particles surrounding it. Due to the size difference, the rate of diffusion of a sucrose sugar particle through the water will be slower compared to a smaller particle. Recap. 1. A mass of sugar was added to tap water and sunk to the bottom of the container. 2. The mass of sugar at the bottom of the container started to dissolve into the tap water. 3. As the mass of sugar started to dissolve into the tap water, this resulted in a concentration gradient within the medium. 4. Dissolved sugar diffused throughout the medium in accordance with the concentration gradient, from the high concentration of sugar at the bottom of the container to the lower concentration of sugar at the top of the container. 5. Due to the relative size mass differences of the sucrose sugar molecule, which has a relative atomic mass of 342, and the water molecule, which has a relative atomic mass of 18, the rate of diffusion is slow compared to another molecule diffusing through water such as methanol, which has a relative atomic mass of 34. Why did the widget initially stand up in the sugar solution? It took approximately 22 minutes for the widget to move from a horizontal position at the bottom of the container to a vertical position. What caused the widget to move in this way? Step 1. A mass of sugar is placed into the tap water. The sugar sinks to the bottom of the container. Step 2. The widget rests on the layer of solid sugar at the bottom of the container. Note: sugar did not start to dissolve on the way down. The amount dissolved is assumed to have been minimal and to have no overall effect on what was observed. The column of tap water was initially displaced in an upward direction by the layer of solid sugar that formed below it. Step 3. The solid sugar started to dissolve and diffuse into the tap water immediately above it, which immediately produces a density and concentration gradient. The density of the layer of sugar solution immediately above the sugar layer increases, which means there are more particles in an identical volume. Due to the layer's increased density, it is exerting more pressure in all directions relative to the tap water. The process of dissolving also increases entropy and results in the dissolved aqueous sugar particles having more microstates compared to when it is solid sugar particles positioned at the bottom of the container. Dissolving is an exothermic process resulting in the particles of the sugar solution and air absorbing the thermal energy, which increases the kinetic energy of the particles. This results in an increase of the entropy of the sugar solution and the number of its microstates. Step 4. The solid sugar continues to dissolve and the density and concentration gradients continue to form. The density of the layer of water immediately above the sugar layer increases, which is more dense than the sugar solution layers above it.